Imagine standing before a mirror that refuses to reflect the present. A surface that does not return your face, your movement, or the moment you exist in now. Instead, it reveals something far older, something that existed long before memory, before history, before even time felt meaningful. This is not a mirror made of glass. It is a mirror made of light. But not ordinary light. This light has traveled for billions of years, crossing distances so vast they defy human comprehension. It carries fragments of ancient realities, echoes of moments that no longer exist. When we look into deep space, we are not seeing what is. We are seeing what once was. Every faint glow in the darkness, every distant shimmer scattered across the night sky is a message encoded in photons. Tiny packets of light that began their journey long before Earth formed, before oceans gathered, before life sparked into existence. This is not reflection. This is time unfolding before our eyes. And this is the true purpose of the most powerful space observatories humanity has ever built. They were never just about seeing farther. They were about seeing earlier. For decades, scientists believed they had a clear picture of how everything began. According to the widely accepted model, the universe emerged about 13.8 billion years ago in a moment of unimaginable density and energy. Space itself expanded, carrying matter and time outward in every direction. In those first moments, the universe was hot, chaotic, and nearly uniform. But as it expanded, it cooled. Energy transformed into particles. Particles combined into atoms. Hydrogen and helium drifted through a vast and silent cosmic ocean. Then came a period known as the Cosmic Dark Ages, a time before stars, before galaxies, before visible light filled the universe. The cosmos existed, but it was hidden in darkness, waiting for something to break the silence. Gradually, gravity began to shape that darkness. Tiny irregularities in density started to grow. Matter gathered into enormous clouds that collapsed under their own weight. As they became denser and hotter, something extraordinary happened. The first stars ignited. These first stars were nothing like the stars we see today. They were massive, unstable, and short-lived. They burned intensely, flooding the universe with light for the first time and ending the cosmic dark ages. From their formation came the earliest galaxies, primitive structures that, according to long-standing theories, should have been small, chaotic, and disorganized. The expectation was simple. The farther we look into space, and therefore back in time, the simpler the universe should appear. But reality did not follow expectation. As observations reached deeper than ever before, faint regions once thought to be empty began revealing hidden detail. And what appeared was not simplicity. It was complexity. Galaxies that should have been in their infancy appeared surprisingly mature. Some showed clear rotating disks. Others had dense, bright cores surrounded by organized systems of stars. A few even hinted at spiral-like patterns, structures that, according to existing models, should not have existed so early in cosmic history. It was as if the universe had grown up too fast. At first, scientists doubted the measurements. Perhaps the distances were wrong. In astronomy, distance is often measured by how much light has been stretched as space expands. If that interpretation were flawed, these objects might not be as ancient as they seemed. But repeated observations told the same story. Again and again, the data pointed in the same direction. These galaxies were real, and they existed astonishingly early, only a few 100 million years after the beginning. In cosmic terms, that is almost instantaneous. Like discovering a fully built city where only foundations should exist. Then came another surprise. Light reveals more than shape, it reveals composition. By analyzing the patterns within light, Scientists can determine which elements exist inside distant stars and galaxies. What they found was deeply unexpected. These early galaxies already contained heavy elements: carbon, oxygen, nitrogen, even iron. But such elements are not created at the beginning of the universe. They are forged inside stars and scattered into space when those stars die. New stars then form from that enriched material. It is a cycle. And cycles require time. Yet somehow, this cycle had already happened far earlier than predicted. This suggests the early universe may not have been slow and gradual. Instead, it may have been intense, rapid, and highly dynamic. Stars may have formed quickly, lived violent lives, and enriched their surroundings in a fraction of the expected time. Rather than a quiet beginning, the early cosmos may have been a place of constant transformation. And the mysteries did not end there. The chemistry that leads to life may not be rare. It may be universal. As if the potential for life was written into the universe from the very beginning. The deeper we look, the more the universe challenges what we thought we knew. Instead of a simple progression from chaos to order, we see structure appearing almost immediately. Galaxies forming faster. Stars evolving sooner. Complexity emerging earlier. Each discovery brings new questions. Each answer reveals deeper uncertainty. The tools built to confirm our understanding are now reshaping it. We set out to see deeper into space.